All right, in today's section, we're going to cover 5.1, solving inequalities with addition and subtraction. This is on page 285 in your book, so you might want to turn to that page now, open up your notebooks, and we'll get started. Please excuse my voice. I am a little sick, just getting over something, so bear with me as we struggle through this together. So over the course of this book so far, we've covered equations. And we've learned how to solve equations, and we've learned that equations have an equal sign in the middle, like you see here. What we're going to move into are inequalities, and inequalities are going to use different signs than the equal sign. Okay, with an inequality, you're going to see a less than or equal to, greater than, or greater than and equal to. This is because one side is not going to be equal to the other side like it is in an equation. Equality signs down for you once again here. What we're going to have on this side is the greater than. This is this side is called the greater than. This one here that I'm going to do is called the greater than or equal to. Okay, you'll notice that you have the line under it right here. And on the other one, the greater than, you do not have the line underneath it. Okay, the other one that we haven't mentioned yet is the less than, which faces the other way, and less than or equal to. And again, I recommend that you write these down or memorize them. Now, some people will teach that this looks like an alligator and that the alligator always eats the larger number, which is a way that you can think about it if you want to. This being this right here, being the mouth of the alligator, right here, wherever it opens, being the mouth, and the alligator is always hungry, so we can draw little teeth in there, give him little eyes, and he always wants to eat the larger number. Okay, here's his teeth. I'm a horrible artist, but you get the picture. Anyway, you have greater than or equal to with the line underneath, less than, and less than or equal to with the line underneath. I'm going to go back and I'm going to spend just a little bit of time talking about equations. And like we've been doing for the whole first part of the year, we've been used to solving things that look like this because they have an equal sign. Okay, and I'm going to try to use money in order to explain this inequality business. Let's pretend that I have a nickel, like I have here. If I'm going to do an equation, whatever's on the other side must be equal to that nickel. So for that to make sense, I can't have a quarter there because a quarter is bigger than a nickel in its value. I could have a $20 bill there because they're not equal. The only thing out of these bills that I could have is another nickel because a nickel is 5 cents, so a nickel can only equal a nickel. However, that's not the case when we're talking about inequalities. Remember the signs that we just talked about a couple slides ago? We had greater than, less than, greater than or equal to, less than or equal to. In this case, let's say that I had my nickel, but then I had less than. So what this sign means right here, the sign right here, is that the nickel is less than something that's over here. So what we can go through is we can go through all of these possibilities up here and put over here whatever is worth more than a nickel. So when I start going through, I can put $1 there because $1 is worth more than a nickel. I could put a dime there because a dime is worth more than a nickel. I could put a quarter there because a quarter is worth more than a nickel. A $20 bill there because a 20 is worth more than a nickel. And a 5. All of these in this part right here, all of these are worth more than that nickel is. What I cannot include is this nickel. This nickel is not worth more than the nickel. When I can include that nickel is if that equal sign is underneath. This reads, a nickel is less than or equal to, and that equal to is key. The nickel is less than the $1, the 20, the dime, the 5, the quarter, but it's also equal to the nickel. So now we can include the nickel. That, once again, that or equal to is key here. What we obviously can't include is the penny. If we try to include the penny, then our statement would be false. The nickel is not less than or equal to the penny because the penny is less. Let's say we change our sign, and this time we're going to use greater than. And let's do the coins. Let's use the dime. The dime is greater than which one of these money? Well, the dime is not greater than the 20, so we'll rule that out. It's not greater than the 1. It's not greater than the 5. It's not greater than the quarter. The dime is greater than the nickel. And the dime is also greater than the penny. So either one of those would work. Now pay attention here because we don't include the dime in this case. Why? Because there's no equal to. If we were to add that equal to, now this reads that dime is greater than or equal to the nickel, the penny, and now we can include the dime. The dime is greater than the nickel, the penny, and it's equal to the dime. I hope this explanation helped more than it confused you. If it didn't, you can rewind and you can listen to it again. That's the great thing about videos. Or you could plug along and we'll go over some examples using inequality right now. So let's start by doing some examples. I'm going to start by doing example number 1 on page 285 in your math book. You'll see that the question is x minus 12 is greater than or equal to 8. I want to bring your attention one more time back to equations and when we were solving them. X minus 12 is equal to 8. What we're going to be doing is we're just solving these inequalities just like we did equations. So when I'm working over here to undo this to solve for x, I would simply add 12 to both sides. Add 12, add 12, cross that out, and I would get x equals 20. Those same rules are going to apply for inequalities as well. When I go to solve this over here, I'm going to still add 12 to each side to cancel those out. And I'm going to be left with x is greater than or equal to 20 because 12 plus 18 is 20. Now here's the difference in our thinking. All right. Over on this side, x can only equal 20. That's it. Okay? For this equation to be true, x can only be equal to 20, and here's why. If 20 minus 12 equals 8, If it's any other number than 20, it's not going to be true. Let's try 21, for example. 21 minus 12 is 9, okay? So this is not true, while this is. So take a look at with me over on the right-hand side, where we have x is greater than or equal to 20. While the left side is saying that x can only equal 20, the right side is saying that x can be any number bigger than 20 or equal to 20. So let's try this with a few different examples. Let's put in first 20 for x. Okay, when I solve that, I get 20 minus 12 is 8. And we read this 8 is greater than or equal to 8. That's true. That counts. That checks out. Now, if I look back up my answer, x was any number that was bigger than or equal to 20. So I tried 20. Let's try a number that's bigger than 20. Doesn't matter what number. I'm just going to choose, I don't know, 30. 30 is bigger than 20, so let's plug in 30 for x. 30 minus 12 is bigger than 8. Let's check it out. 30 minus 12 is 18, and 18 is greater than or equal to 8. So that indeed is also true. Here's the thing. With inequalities like we have here, you're going to have a lot of different answers. Over here on the left, we have just x equals 20. But over here, we have x can equal 20, 21, 22, 23, 24, and so on. You get the picture. Any number that's bigger than 20. The key thing is to remember that and that you solve inequalities the same way that you do equations. I'm going to write down a couple of examples. These examples are in your book. Okay. The first example is 22 is greater than m minus 8. And the second one is d minus 14 is greater than or equal to negative 19. And what I'd like you to do here is to solve this, to stop this video at this point and solve these problems, and then go through and unpause it. When you're finished, unpause it. We'll solve these together and we'll see if you got them right. So pause this video now. Okay, let's take a look and see how you did. For number one, the first thing that I'm going to do is I'm going to add 8 to both sides. Add 8 and add 8. This part is going to cancel out. 22 plus 8 gives me 30. I bring down my sign, which is the greater than sign, and I bring down the m. Now I'm finished. This kind of looks interesting to me. Usually what you'll see is you'll see the variable, in this case our m, written on the left hand, not on the right hand side. So I'm going to rewrite it. I'm going to put the m on the left and 30 on the right. Now when you do that, it's key that you take note of what your sign was. Okay? In this instance, we're not just going to bring down the sign because we'd get it wrong. We want to switch the sign. Take note. The open end is facing towards the 30. So when we switch it, we want the open end to still be facing the 30. This right here should be our answer. And what that means is that m is less than or equal to 30. M can be any number less than 30. It cannot be 30 though, because there's no equal sign underneath that. Let's try number 2. For number 2, we have d minus 14. is greater than or equal to negative 19. So to solve for that, I'm going to add 14 to both sides. Cross those out because they cancel. Bring down the d. Bring down my greater than or equal to sign. And I get negative 5. So I have d is greater than or equal to negative 5. And that should be our answer. The variable is on the left-hand side, and so I'm good with that. I'm going to keep it just like that. D could be any number that's bigger than or equal to negative 5. And notice that negative 5 would be included because we have the line underneath. If you would like another example, here it is. C minus 12 is greater than 65. You can pause it here quickly if you want to do this on your own. Otherwise, I'm just going to solve this and give you the answer. To solve this, I'm going to treat it just like an equation. Add 12, add 12. That cancels out. Bring down my C, bring down my greater than sign. 65 plus 12 is 77. So I have C is greater than 77. Let's go back and revisit for a moment one of the examples that we just covered. We had 22 is greater than m minus 8. And we did a good job at solving this. We added 8, if you remember. Got 30 is greater than m. And then we switched it around so that m was less than 30. One thing that you're going to be asked to do is you're going to be asked to graph. You're going to be asked to graph this solution. And I'm going to show you how to graph that. Okay? Here's how we're going to graph. Here's a couple of things you need to know. You need to use a colored in circle like this. And yours can be better. Use a colored in circle when you have less than equal to or greater than equal to. I would write that down in your notes. Use an open circle when you have either less than or greater than. Okay? So here's how we're going to graph this. We're going to start by creating a number line. Okay? Here's my number line. It doesn't have to be real fancy. It needs to be nice. It needs to be neat. It needs to be legible. Okay? But it doesn't have to be something that's going to win the Nobel Peace Prize or something like that. So I'm going to look up at my answer. My answer was up here. M is less than 30. So that I know that my number line needs to be somewhere around the number 30. Let me circle my answer there. So I'm going to start my number line, let's say, right at 30. And then I'm going to do a couple numbers bigger than 30. And I'm going to do a couple numbers smaller than 30. So there's my number line. And now I look up at my answer again. And when I look up at my answer, I see that I have m is less than 30. That means that I have to put a circle at 30. Do I put an open circle or a closed circle? I'm going to put an open circle if you wrote this down in your notes, which I suggest that you do. You use an open circle when you have less than or greater than. Here I have less than. And so I'm going to do an open circle at 30. Now I just need to figure out, I need to draw an arrow, and I got to figure out which way I need that arrow to go. Does it go left, or does that arrow go right? Well, in this case, all of our answers are going to be less than 30 because m has to be smaller than 30. And so I'm going to draw my arrow going to the left, meaning that all of the numbers to smaller than 30 are solutions. And now I've graphed my answer. Let's try to graph another one. C minus 12 equals 65. You should already have the answer to this problem as well, but we'll redo it anyway for some practice. Add 12 to both sides, and that should not be an equal sign. I apologize for that. That should not be an equal sign. Let's do greater than or equal to. I'm still in the mode of doing equations too. Anyway, 65 plus 12 is 77. So now what we have is C is greater than or equal to 77. And we're asked to graph this answer. And so to graph it, like I explained to you before, I'm going to start with a number line. Here's my number line. The number that I have is 77. So I'm going to start with 77. And I'm going to do a few bigger than 77. And I'm going to do a few smaller than 77. Now my circle is going to go on 77, and I have to decide, is it going to be an open circle or is it going to be a closed circle? What do you think? Hopefully you said closed. Why is it going to be closed? Because of the equal sign. Hopefully you said that as well. Now what we have to decide is, which way is our arrow going to go? Our arrow can either go to the left or it can go to the right. In this case, C is all numbers bigger than 77. And so I'm going to draw my arrow to the side with all the numbers that are bigger than 77. In other words, to the right. So there's my answer, and it's graphed. Solving these inequalities with subtraction is the same as solving them in addition. You just do the inverse operation. So let's say we have m plus 19 is greater than 56. To solve this, treat it just like you would an equation. Subtract 19, subtract 19. You're going to cross that out. You get m is greater than 37. And then you're finished. Now, if you needed to graph it, here's how. Let's graph it again. Let's get in the habit of graphing, because if your directions in your homework say to graph your solution, then you need to graph it. Okay. So my number starts at 37. I'm going to do a couple numbers larger than 37. I'm going to do a couple numbers smaller than 37. I'm going to put my circle on 37. Now, should I fill this one in or should I leave it open? I'm going to leave this one open, okay? And now I need to decide, am I going to go to the left or am I going to go to the right? Hopefully you decided that we're going to go to the right. If you did say we were going to the right, then you would be right, because you could see here that m is bigger than 37. And all these numbers over here are bigger than 37. Okay, here are two more examples for you to try. You need to solve these for x, and then you need to graph them. So two things you need to do. If you don't do one or the other, then you don't get the question right. So number one, solve. And then when you do that, you need to graph. Go ahead and pause here, and then unpause when you're ready, and we'll work these through together. Okay, for number 4, let's attack this one first. To solve, I'm going to minus 8 and minus 8. I get p is less than or equal to 10. And now I need to graph that if I'm going to get all the points possible. Here's my number line. Here's 10. I'm going to do a couple numbers larger than 10 and just a few smaller than 10. Okay. I'm going to place a circle at 10 and I'm going to fill it in because of the equal sign that's underneath the less than sign. And then I'm going to go to the left because P is all the numbers smaller than 10. For the one on the right, I'm going to minus 23. I'm going to minus 23. This cancels out and I get X is less than negative 9. Now I need to graph it. And so even though it's a negative, I'm going to graph it just like normal. Although you have to be careful when you're working with negatives. Here's why. Because when you're graphing ones that are bigger, negative 8, negative 7 are actually bigger than negative 9, while negative 10 and negative 11 are smaller than negative 9. My circle goes at negative 9, and I'm going to leave it open because there's no line underneath my sign. And then I'm going to go to the left because X is all the numbers smaller than negative 9. And there you have it. If you solve these and graph these perfectly and you got the right answer, I think you're well on your way to understanding what we're doing. We only have one more thing that we need to cover. Okay, the last thing that we need to do for this lesson is we need to work on solving variables on both sides. And if you need to, you can write this down. It's not too complicated. There's going to take you 2 steps to solve these inequalities when you have variables on both sides. And here's what I mean by that. Here's an example. If you have 3a plus 6 is greater than 4a, here you could see that you have a variable on the left side and you have a variable on the right side. We have variables on both sides of our inequality sign. Okay? So to do that, all you have to do is one step at the very beginning, and that step is to get the variables on the same side. It doesn't matter what side you get it on, but you want all the A's on one side. Either move the 4A over here or move the 3A over here. It's your choice. Taking a look at that example, let's say we were given 3a plus 6 is less than or equal to 4a, and we were asked to solve and then graph the solution, like we are asked to do on page 287. That's where this is in your book, by the way. That's where I am. Okay? Going back, remember that the first thing was to do is that we needed to solve by getting the variables on the same side of the equation. So I'm going to do that by minusing 3a, and then I get 6 is, oops, need to make sure I break down the right sign here. Bear with me. Less than or equal to 4a minus 3a is just 1a, or 6 is less than a. Now remember what I said at the beginning is usually the variable is written on the left and the number is written on the right. So I'm going to switch this around and I'm going to make the a on the left, the 6 on the right. Take note that it's opening towards the a, so that should be my answer. Now these two are saying the same thing, but you're more likely going to see the bottom one in a textbook or in a solution or on a test. But essentially they're saying the same thing. Okay? Before I forget, let's make sure that we graph because we were asked to graph. Gonna draw my number line. Okay. It starts at 6. Do a few bigger. Do a few smaller. Not to mention, when you go to graph, having the variable on the left, like you do here, will help you to be more efficient when you come to graphing these. Because what this is saying is A is greater than or equal to 6. So I know that my circle goes on 6, and A has to be bigger than 6. So it's going to be all the numbers to the right of that. I'm going to give you just a couple more examples to try on your own. All right. The first example can be found on page 287 in your book. It's 9n minus 1 is less than 10n. And the other example is going to be 5h is less than or equal to 12 plus 4h. Both of these have variables on both sides. Pause this video here, solve these on your own, and graph them on pause when you're ready for the answer. All right, let's go ahead and let's solve this thing. What I'm going to do is I'm going to try to get my variables on the same side, and I just realized that I forgot to give you the variable. So that is 100% my fault. Sorry about that. But again, it was on page 287, so if you're looking in your book, you would have been able to catch that pretty easily. So I'm going to solve this. I'm going to get my variables on the same side. I'm going to subtract 9n and subtract 9n. Cross that out. I get negative 1 is less than n. I don't like my variable being on the right, so I'm going to switch it and the sign to look like that. And then when I graph it, I'm going to put negative 1, 0, 1. I'm going to put one number less just because I ran out of room. Open circle. And n is got to be bigger than negative 1. So I'm going to go to the right. Let's check this one here. Over on the right-hand side, I'm going to minus 4h, minus 4h. 5h minus 4h just gives me h is less than or equal to 12. That would be my answer. Now I need to graph it. So when I graph, I'm going to start with 12. I'm going to do 13, 14, 11, 10. My circle goes at the 12. I'm going to fill it in because of the line underneath says it's equal to. And h is less than 12. So I need to go to the left. And then I'm finished. All right, for your homework is going to be on page 288, and you can do numbers 9 through 29. Not that much, not too bad. Everything should be self-explanatory. If you need, you can look back at your notes, replay the video, whatever you need to help you get a good score. All right. With that being said, I think that's all we have for this time. Hope it was clear. Hope you understand. If you have any questions, let me know. And we'll talk to you next time.